Hello everyone, today I am going to do this control rig based 𝐒𝐴 foot placement system for the mannequin. So as you can see here, now the character can properly place the foot when it climb on the staircase like this. See, the both foot are placed properly and firmly on the ground. Alright, so let's see how to do this today. And as I said, I'm going to use this control rig for the in Unreal Engine 5, not the conventional animation blueprint based calculations that we did in Unreal Engine 4. And this episode is sponsored by these generous patrons. Thank you very much for your support. Okay, so last time we worked on this control rig for the mannequin character, and today I am going to work on, so this is the preview of the control rig. So today I am going to work on using this control rig. I'm gonna implement a foot placement system. So in case you don't know, foot placement means, like as you can see here, when the character stands in a place like this, you can see the foot, one of the foot is the right foot is above the floor. Yeah, the same thing happens here as well. So we need to firmly place it on the ground, both foot, left and right. So let's see how to do that using control rig. Right, so first we need to use the control rig in the in our animation blueprint. So this is the third person character. If you select the mesh, you can see which animation blueprint class has been used. Click on the magnifier and double click, so you can open that particular animation class blueprint that has been used with the character. Now in the anim graph, when you go to the anim graph, this is what you see. So in order to use the control rig, so actually I am planning to use it not in the jump state, so any other states. So I'm only going to use the control rig in this ground movement, especially only for idle part, when the character is just standing on the ground. Right, so for that we can, if you type control rig, you can get a control rig now, and when you select, you have to select the control rig class. So I'm gonna select 𝐂𝐴 control rig, which is the control rig I have created here, this one. Right, now if I compile, the alpha is 1 already, so this will be automatically applied. And if I play, you can see character looks kind of weird position and the foot is not moving. That's because here I am controlling the foot using these controls like this, and they are not changing. So that's the reason. Okay, now first thing is, this control rig should be applied only when the character is in a character is standing still in the idle animation. So for that we can do something like this. Let me promote this alpha to a variable. Yeah, let's name it as control alpha. By default it should be 0. Oh, 0, not 1. Right, and in the event graph where we calculate the speed, we can divide this by some value. we can interpolate, we can lerp the value of alpha, control alpha. Set control alpha based on the speed. So when speed becomes 0, this should be 1. When speed is higher, this should be 0. The control alpha should be 0. So to do that, let's divide this value like 50 and clamp it in between 0 and 1. Then we can use a linear interpolation or a lerp node. So as I said, when the speed becomes higher, control alpha should be 0. When speed becomes 0, control alpha should be 1. So we can use 1 minus value here. So we can achieve what I just explained. And I'll use alpha like something like this, and for the A I'll just connect the existing value of control alpha. So we will have a smooth interpolation from whatever the value to 0. Let's see. Yeah, okay, that seems fast enough. Right, now we need to work on the logic to how to determine the flow location and move the character, the foot and the hip, to make the foot place on the floor. So okay, to do that here, so here we need to know a couple of things. So let me explain this maybe with an image. Right, so when we need to make sure, yeah, here we have this foot location, left foot here and right foot here and the pelvis here. So by calculating by adding these two locations together and dividing it by 2, we can get the middle point in between these two foot locations, and then we can calculate this height or the offset between this middle location and the pelvis that this character needs to have, that this character will have initially. So let's say I'll call this one H. This is a vector, right? Then let's say the character is in a position like this. Let me slightly raise one of the legs. So the character needs to place, let's say, in a staircase. The character should be in a position like this. In that case, what I have to do is, let me consider this angle. Again here, still we can access these two locations, but the XY location of the pelvis can be taken by averaging this point and this point. So we will get some, or if we consider only the XY, we will get some point along this line. And how do we get the offset? This H should be the difference between this lowest point, the lowest foot, it could be either right or left depending on the case. From the lowest foot we should get h amount of height, so z difference should be taken from the lowest point. So we will get, or as for the pelvis location, somewhere like this. So h would be the difference. So that's what I am going to do here, right? So in order to determine the foot locations, I have to do a line trace. So let's create a function, trace flow. Now let's call it trace foot, right? So here let's do a line trace. Oh, we can't do line trace, we have sphere trace by channel. Okay, this will do. Right, see here as a starting location I can get, I'm gonna use the polar location, get transform, and if I press this one, now I can access separately translation. Oh, no need to divide that. So if I add another 100 here, we will get a point above the ball R. That means this bone, this is right here, we have the ball R, some point above here, and for the trace end I need a point below that. So again take this, add minus 100. Okay, so these two going to be the starting location and ending location of the line trace. Sorry, not line trace, sphere trace. Radius is 5. So yeah, and if we get a hit, that location should be the new location of this ball, no, not the ball R, IK ball R control. So since we are controlling the foot IK using this IK ball R and IK ball L, we can move the foot locations by changing the locations of IK ball R and IK ball L. So drag here, set control, oh wait, set translation, because at the moment I don't want to change any rotation or anything. Right, now here as the translation, yeah, we should get this hit location only if there is a hit. So we can use a if node here. If this is a hit, true, hit location should be the new location of IK ball R. If there is no hit, then the location can be, oh wait, I think we can use this weight. Yeah, so if this is a hit, weight should be 1, otherwise weight should be 0. Okay, right, now I'll promote this name of the bone as a parameter. Let's call this one bone, and also this one as a parameter, so we can use the same function for the right leg as well. Control. Right, now let's trace foot. Let's see if we can see any difference. This is not complete. Yeah, you can already see the right foot is kind of straightened out here, but it's not placing on the ground because we can't stretch the leg. We have to move down the pelvis as well. Alright, so let's use the same function for the right leg as well, sorry, left leg as well. Ball L and IK ball L. Right, now we should see some weird stiffness for both legs. See, okay. Alright, so far it is working. Now let's work on how to adjust the pelvis. Alright, so for that let's add another function, adjust pelvis. So here what we need to do is well, I am not going to set up any controllers for the pelvis as for this, so I'm just directly going to set the location of the pelvis according to the logic I explained here. So first we need to find this edge. Right, so for that we need to know the initial locations of ball R and ball L bones. Ball R and ball L. Let me drag and drop ball R, get transform. So here make sure you are getting the initial transform, it's because we are still at the moment we are trying to calculate H, and also ball L. Here also initial. So we are only interested in the translation at the moment. So now we need to find out the middle position of these two vectors. So let's lap these two vectors with 0.5, so we will get a middle point. Right, now I'm gonna assume this is going to be directly below the pelvis. Then if I get the pelvis translation, get transform, here also it needs to be initial, and if I subtract this bone from the pelvis location, now here as the result of this operation we have this H vector I explained here. Right, now when the both foot is in two places, the hip needs to be adjusted as I explained here. So first we need to get the locations of these IK ball L and IK ball R controllers, because these are the controllers I am changing in this trace foot function. So here we need the current location, not the initial location. Translation. Let's club these two. Okay, ball L. Oh, we can't type here. Okay, ball R. .5. Right. Then we can set the pelvis location, but not the complete transform, only the location. Set translation. It would be better if I control the pelvis also with a controller, but let's just try directly changing it for now. So here the translation. As I said before, the X and Y part will directly come from here by taking the middle point of ball L and ball R. It may not be 100% accurate, but let's just go with this for now. Right, and is it that has to be the lowest point, and add. So to get the lowest point, we can get minimum value out of these two. Then to this we need to add the edge height difference. So this one, and that should be the Z part. Okay, now let's add this function also. Adjust pelvis in here. Compile. Shall we test or wait? Oh, here there is something not happening. Alright, the reason is we need to propagate to children. It's a bit unrealistic as I said, but let's see how it looks here. Now you see the foot is adjusting, but character bends forward a little bit, which is not good. But the foot adjustment is working. See? Right, so we will have to improve this because you can see the angle of the foot is not correct. And also there should be some offset from the control because somewhat the foot is somewhat submerged. Okay, yeah, I think instead of just adding the Z, what if we add this whole vector here? Yeah, let's try that. So the XY component as well. This is still bending forward. Oh wait, I didn't use it yet. Yeah, now the character is straight, but foot is somewhat submerged. So for that, what I have to do is adjusting the offset between this foot ball L and control IK ball L control offset. Yeah, actually there is a way to fix this submerging issue on the ground. So yeah, let me show it again. So you can see this left foot is a little bit in the ground. So what we can do is here, let me break this, and if I go to left view, you can see the IK ball L control and IK ball R control is like this, but we need to match these controllers to the bottom of the foot. So let me move this like this and set initial transform from the current. Similarly this one also, move down, right click, set initial transform from the current, and connect again. Now we can see it's properly placed on the ground. And if I go back, see, now it's not submerged anymore, and when I am here you can see it's properly placing on the staircase. See, okay, that's better than before, right? So okay, I'm gonna stop this episode right here, and thanks for watching. So as always, project files will be available for the download through Patreon page, link would be in the description below. And if you like to support my work, you can get the membership of the Patreon club. See you in another episode. Goodbye. And yes, I will continue to do some more episodes on this control rig to make it perfect.